When you are differentiating an implicit function like this one here, we use what we call implicit differentiation, meaning that each term has to be differentiated separately. For the definition of implicit functions, there are those functions like this one here where you cannot write y as a function of x or make it the subject. You cannot separate the y from its x variable. Let's see how we can accomplish the implicit differentiation for this function. Differentiating implicit functions involve differentiating each term on its own. So we're going to do that by using the derivative operator d of 2x with respect of dx, and we do the same thing for the term 3y. So we're going to do d 3y with respect of dx, so derivative of 3y, and we do the same thing for the term 5xy. So we're going to take the derivative of that term 5xy with respect of dx, and the same thing goes to the right hand side terms one by one. So we do derivative of 2x squared y with respect of dx minus the derivative of 3xy squared with respect of dx as well, and finally derivative of the constant 5 with respect of dx. Alright, so let's go back to the left hand side and start with this one here. What is the derivative of 2x by dx, or with respect of 2x? Well, it is same as saying the derivative of 2x or 2x dash, and that we know is 2. Right, so that one is 2 minus, for 3y by x, we need to apply the chain rule to get it correct, because y is a function of x. It is in terms of x. So in order to differentiate 3y with respect of dx, we need to first differentiate 3y with respect of dy, and then differentiate dy with respect of dx. We'll multiply by dy by dx, because then 3y, the derivative of 3y is similar as saying 3y dash. That is going to be just 3, right? So basically this is going to be, or this will give us 3 dy by dx. So that is the second term there completed now. 3 dy by dx. Let's do the next one. Derivative of 5xy with respect of dx. This is a product rule. As you can see, you got 5x times y. Alright, so that is my u, if you like, and that is my function v. So we need to take the derivative of 5x first. So we're going to put the 5x inside the derivative of the operator, and y stay outside, meaning we do not differentiate it. And then in the second part of the product rule, we need to keep 5x outside the operator, and the y stays inside with respect to dx as well. So let's do each differentiation separately here on this line. So we know how to differentiate 5x is similar to basically what we did. The 2x is mainly 5 and times it by y. That gives us 5y. All right, 5x here. And for dy with respect to dx is similar what we had here. Here we had 3y, but here we have 1y, but the procedure or the process is exactly the same. So therefore we get instead of 3y we get 1y. So 5x sorry, we get 1, apologize. So we get 5x times dy by dx. Because this one here, if I just do the working out quickly, you do dy by dy, you apply the chain rule, and it times it by dy by dx. Right? That's what you need to do to differentiate this one, because y is a function of x. All right. So dy by dy will cancel out, if you like, and give us 1, and that's why we get 1 times dy by dx, and that's why we've got this operator there, dy by dx. So that is 5y plus 5x dy over or by dx. So that would be for this term here. So let's write it down here. Should be plus, actually. 5y plus 5x dy by dx. So let's do the right hand side. So we're doing the derivative of 2x squared y with respect of dx. Same as we did here, it is a product rule, and then we do the chain rule. So let's do the product rule first. My function u is 2x squared, and this one here is v. So we're going to differentiate first the 2x squared with respect of dx, times it by y, right? And then we're going to keep the 2x squared outside the derivative operator, and y will go inside the operator. So for this one here is same as differentiating 2x squared. We know it is 4x, right? You bring the 2 down, so you multiply it by 2, that gives you 4, and then you reduce the power by 1, that gives you power 1, or just x. So that is 4xy. Okay, so that is 4x times it, because there's a time there, y. So in algebra, it's just 4xy. Now for the next one is, again, we are using what we did here, the chain rule, but because it's just a basic y function, so it will give us 1 times dy by dx, as we explain here. So there is no need to do it again. So this will give us 2x squared dy by dx. So this goes here. All right? So let's write it down for xy plus 2x squared dy by dx. All right, and then we're going to do plus, no, minus actually, this one here. So that will go down here. So we're doing the derivative of 3x y squared by dx. Again, similar, we're doing the product rule, and then we do the chain rule. So that is my u, that is my v. So we're doing the derivative of 3x by dx times y squared, yeah, and then plus we're doing the 3x times the derivative of y squared by dx. Okay, so for this one is similar again to what we did earlier, like this one there, right? So we will get 3y squared, because the derivative of 3x by the x, I can show you the working out. So you take the 3 outside the operator, you don't need the bracket now, so that times y squared. So therefore the dx by dx will cancel out to 1, if you like, or it will give you 1. So the answer is 3y squared. Now for this one here, we need to apply the chain rule. So let's write it down here. D of y squared with respect of dx is going to be d of y squared with respect of dy. So we need to differentiate it with respect of y, and then do dy by dx. That is the idea. Now if you do this, it's same as differentiating y squared with respect of y. That gives you 2y, right? So therefore this is 2y, and that is dy by dx. So altogether here we'll have 3x times 2y, which is 6xy, followed by dy by dx. Okay, so that is this one here. If I can find room to write it down, 3y squared minus 6xy dy by dx. dy by dx. So you have to be careful here because there is a plus there where there is a minus there. Just bear that in mind. And then the derivative of the constant 5 would be, of course, equal to 0. We want to differentiate, of course, the implicit function, so we need to write it down as dy by dx equals something. So we need to bring all the dy by dx to the left hand side and make it the subject. These are the dy dx, this one here, this one, and this one. So all these have to be on the left hand side. So let's rearrange our equation. It will be minus 3 here, plus 5x, okay? And then I'll bring this to the left hand side. It becomes minus 2x squared. And this one here becomes plus 6xy. This is on the left hand side. Now on the right hand side. So I got this one here already there, 4xy. What else I've got? Minus 3y squared. This move to the right hand side becomes negative 2. This also moves to the right hand side, becomes minus 5y. So we've got everything now. All we have to do, divide by this bracket here. So finally dy by dx is equal 4xy, that is 4xy minus 3y squared minus 2 minus 5y divided by negative 3 plus 5x minus 2x squared plus 6xy, and that is the final derivative of the implicit function. I hope this video was helpful. Thank you for watching and take care.